Hello, everyone. So what I'm going to go through today is a business case I was working on at my company, Ubiquity Networks. It's a wonderful company that pays me money to code in my favorite language, the one language that I fell in love at first sight. It never happened to me before as much as I love programming. And so what I was working on is a RESTful HTTP server handling audio configurations. So our server gets an audio configuration that looks something like this. This would be a text greeting and the audio formats that needs to be converted to. So our HTTP server is a RESTful server that does the usual RESTful stuff like add, update, delete, fetch. We won't be talking about it. We'll be talking about the fun stuff it does is the audio conversions. So this text will be converted to an audio, and the audio will be converted to other audio formats. And these audio files will be saved to S3. And as they are saved to S3, we'll be saving the audio IDs to our database to indicate that they are available for upload from S3. So that's in a nutshell what our server is doing. So a couple of things we need to consider implementing such a server. Audio conversions are very CPU intensive. Saves to S3, on the other hand, are easy on the CPU, but might take a very long time. And basically not very long time, but unpredictable amount of time. Also, considering that this request can't be fulfilled very quickly, it will have to take some time. So it will be an asynchronous request. We will be responding immediately to our client and asynchronously proceed with fulfilling the request. So as a particular audio is being processed, we don't want another request for this same audio to, another update request for this same audio to be processing. So how do we approach this problem in Erlang? We create a finite state machine for every audio request that comes in. It could have been a Gen server. We just decided on finite state machine at that time. So a request comes in, we spawn a new FSM, and another request comes in. We spawn another FSM, and another request comes in, we spawn another FSM, and we're gonna spawn a separate process for every single request that comes in into our HTTP server. So you'll be getting tired of these FSMs I'm gonna be spawning on the screen here. But our server will be getting hundreds and thousands of such requests, and we'll be creating spawning a separate process for every single one of them. And if you think it's a crazy thing to do, it is not for an Erlang developer. It's perfectly normal to spawn hundreds, thousands of processes as long as it makes makes business sense. And that is because Erlang processes are cheap, and as a developer, you don't have to worry about how it's going to work. Erlang VM will distribute the load evenly across the underlying OS threads, and you, as a developer, you can just spawn as many processes as you want. So next, audio conversions. It's not a novel problem converting text to voice or converting various audio formats. It's already been done before us. So we use existing C executables to perform audio conversions. So for text to voice conversions, we use the Substral service. And for converting the resulting WAV file to other audio formats, we use SOCs. However, if in your situation you need to run some kind of computationally intensive task and you need to write your own, it is a good idea to write it as a single unit of code in C because manipulating large data structures in Erlang, running computationally intensive tasks is not such a great idea, considering that data structures are immutable in Erlang. So you should consider writing a single unit of code in C, and then have Erlang manage them running concurrently. And I would like to quote our very famous Garrett Smith: think of Erlang as a manager, not a worker. Next problem solved S3. So we are this finite state machine. We are pretty busy doing audio conversions and saving to S3 and saving to the database and orchestrating the whole audio, orchestrating processing of this audio request. So we have the S3 URL, we have our audio binary.
Hi, it's Jim. Call me back.
But we can't afford sending the S3 request and sit there waiting for it to complete. So naturally, as an Erlang developer, what do we decide to do? We just spawn a child process that will do this instead. And so the child process will send the S3 request and wait and do nothing but wait for it to complete. And to get the result, to get notified of the result when the S3 request completes, we equip this process with our own process ID. And let's take a look at the child code. So all it does, it sends the S3 request, and when it gets the result, it sends the result to us and ceases to exist. Now back to audio conversions. As I mentioned, they are CPU intensive. So it's perfectly OK, like I said, to spawn hundreds and thousands of processes. But what if those processes will be all performing audio conversions at the same time? While Erlang VM can distribute the load, it can't give us more CPU power than our machine has. So what's gonna happen is that audio conversions potentially will eat up all the CPU power. There'll be no resources left for other important things like accepting HTTP requests, saving to the database, sending S3 requests. Audio conversions will eat up all our resources, and you'll end up in a situation commonly known as overload. So what can we do? Well, very simple answer. We can limit the number of simultaneous audio conversions to number of CPUs minus 1, and leave one CPU available for other important work. How would we do that? We can always, it seems like a pretty trivial problem, so we can, of course, write our own code to do it. On the other hand, it seems like a pretty common problem, which probably other people already addressed.
I think your mic was plugged.
Oh, no, nobody here. Oh. So this problem has probably been, we are not the first people to think about this, so we maybe should look for an existing library that already does something like that. And considering our tight deadlines and complicated business requirements, we decided to look for an existing library. And the library we used is the jobs framework by Ulf Wigger. It's a job scheduler for load regulation, and its purpose in life is to prevent overload. So I would like you to take a quick look at this article that is the inspiration behind the jobs framework that Ulf wrote in August of 2010. It's actually a very interesting article. If you want to know everything about overload, you might want to read it. And we'll take a look at this diagram, which shows the failures in the US public switch telephony network outage minutes by cause. And as we see, this the largest reason for failures is overload. And I hope this diagram is convincing enough for you to consider preventing overload in your system before it goes into production. How did we use the jobs framework with our audio conversion, with our CPU-intensive audio conversion situation? We used the jobs counter-based regulation. What it is it limits the number of simultaneous jobs of a certain type to a predefined number, and everything else gets queued up until the other jobs complete. This is kind of to demonstrate what it looks like. And now I would like to take you through the entire process of setting up the jobs framework with our HTTP server. Step 1, we need to add jobs to our rebar config dependencies. Step 2, and this is important, this is how we set up jobs env in our app.config. So we create a queue called audio conversions and assign a counter regulator to it with a limit of 7. 7 because I have 8 cores, so it would be 7. 8 minus 1, 7. And next, I just wanted to take a sneak peek at our very complicated business flow. And we don't need to change the flow to actually regulate our jobs. We just simply wrap our audio conversions in a call to jobs server, and voila, our audio conversions are regulated. And here's my code that does text-to-voice conversion. So instead of just this do underscore TTS, just calling that function, I just wrap it in the call to job server. So you might be thinking, OK, so for this magic to work, I need to start a server with my application. And if you're an Erlang developer, it's perfectly OK. It's perfectly normal. But if you're not, you might be actually concerned. And so there is no need to be concerned. As an Erlang developer, it's perfectly OK to start any servers with your application. And you don't have to talk to your boss or your ops team boss for permission on that. And I would like to quote Garrett Smith again. Think of Erlang as an operating system for your code. So to have jobs server running with our application, we'll have to add it to our application startup list. So that's it. That's all we need to do to get our audio conversions counter-regulated. So next, I would like to go through this little video to show what else jobs framework can do for us for our HTTP server. So let's say that these two lovely ladies are our HTTP server, and the chocolates coming in on the conveyor belt are our HTTP requests. So as the requests are coming in at a steady pace and that our HTTP server can handle, everything's great. But what starts happening when the requests are coming in at a much faster pace is really, really funny. Unless it's your HTTP server, and maybe it's your HTTP server in the middle of the night. So to deal with a situation like this, Job Framework offers another great thing. It's rate-based regulation. So So what rate-based regulation does is, given a frequency f, it ensures that the rate of accepted jobs does not exceed f. And this is how we're going to have the requests coming into our HTTP server rate regulated. This is how we set it up in the apps.config. We're going to create a queue called HTTP requests, and we are going to assign a rate regulator to it with limit of 1,000 requests per second. So this number, of course, is not something you're going to use. In order to come up with a good number, you need to test and measure your system and decide what is the optimal maximum pace your server can accept the requests at. So now we have our system counter regulated and rate regulated. So now we can, I guess, have peace of mind. Well, not sure about you, but all sorts of what ifs are creeping in for me. What if we get denial of service attack? Well, but then we say that our requests are regulated, so we shouldn't be too worried about it too much, should we? Well, remember that requests that are being paced are actually getting accumulated in our HTTP request queue. So just watch that queue inflate, and eventually it will blow our server's memory. So what do we do about that? Limit the queue size, and this is how we do it with the. This is how we do it in the jobs configuration. Our HTTP request will have a max size of 5,000. It's an arbitrary number I just came up with. Another what if? What if our requests have a strict timeout? There's absolutely no point keeping requests that timed out in our queue. So for instance, if you're real-time bidding, depending on the provider, your requests will time out within 200 milliseconds. Or on the other hand, if you have some kind of a payment processing request coming into your server, that may not time out at all, or just about anything has a reasonable timeout. So maybe 10 minutes. So just any request, whether it's a very short-lived request or a long-running request, it will still have some kind of timeout. So what we can do is limit the request wait time in the queue. And this is how we're going to do it. So for our RTB requests, we're going to give them a max time of, so we're going to create a new queue called RTB requests. To give it a timeout, we need to create a new queue. And we're going to give it a max time of 200 milliseconds. And we're going to create a new queue payment requests and give it a max time of 10 minutes. So now the question is, OK, but what if I want my request to be paced at a certain pace regardless of what type of request they are? I mean, this is not a realistic scenario, of course, but I just wanted to take some extremes as a good, I thought it was a good example. So let's say we want the request coming into our server to be paced at a certain regulator, at a certain limit, but there would be kind of different types of requests with different max times. So for that, the job framework has a group rate regulation. So it's kind of similar to rate regulation now, but now we're going to be now we're going to be actually applying it to a group of different queues. So the group rate regulator lets us put a cap on how many jobs from a group of queues can execute per second. So now we're going to look at some code of how we're going to set this up in our environment. So we're going to create a group rate regulator. We'll call it HTTP request rate with a limit of 1,000, just like the one we had before. And now we're going to assign this group rate regulator HTTP request rate to our RTP requests. And we're also going to assign this HTTP request rate to our payment requests. So regardless of which one of these requests are coming in into our server, they're going to be only coming in at 1,000 per second. Now back to audio conversions. What if we decide to, what if our assumption that CPU -1 is good enough is not good enough? What if our server is all of a sudden running some other jobs we were not even aware of? They're not part of our code, just maybe some kind of maintenance job. And all of a sudden, we started dropping requests on the queue. We can't update the database because we don't have enough resources. So the answer to that is sampler framework that comes with jobs. And sampler framework allows us to, it actually sends feedback from CPU memory, and we can get load factors from local and also remote nodes. And what that local load factor is going to do, it's going to be a percentage by which to reduce the predefined regulator limits. And a quick note on the remote nodes: when we get multiple feedbacks, we can either take the maximum value or we can take the average value. So this is how we set it up. So when we start our job server, we're also going to start our samplers. And let's say we decide to sample the CPU load. To sample a CPU load, jobs framework comes with the out-of-the-box sampler. It's called job sampler CPU. Then we're going to take our audio conversions queue that has a counter regulator limited to 7, but we're going to apply a modifier to it. And that modifier will be feeding from that CPU sampler. So if the CPU, if the CPU gets busier, we're going to get a certain percentage of that increase, and we're going to apply it to our limit, and this will decrease the limit. And if the system goes back to normal, the limit's going to go back to what it was originally. So next, just a quick note about job sampler CPU. It only works on Linux and Unix because it uses OS mount CPU sub, which only is working on that OS. And let's say let's say you want to run this sampler framework on your Mac, it won't be working. So what we're going to do to get CPU sampler working on our Mac, we can create our own sampler plugins. And jobs framework is very pluggable. And we're going to take a look at some of those features. So to measure CPU on my Mac, I'm going to take a temperature sensor and turn off the fans on my expensive Mac and attach the temperature sensor to it. And I'm going to write my own module called my thermo sampler, and it will implement job sampler behavior. So now instead of using the out-of-the-box job sampler CPU sampler, I will use my own sampler instead. That's how we configure it. Another what if we decide to accept pre-recorded audios? And those can get really big and really large. They can get really big, and they can be of very different sizes. So we get this post request with varying size files that get queued up. And now we're kind of back to the memory problem we had before, because limiting the number of requests to a specific number almost doesn't help us, because if these files get really huge, you know, having and they're not, we don't know how large they are. Having a limited number of things in our queue won't help us. So to answer this question, we can write our own queue. It's perfectly easy to write your own queue with the jobs. It provides it provides jobs queue behavior, and we're gonna write our own queue called, let's say, memory friendly queue. So that one's going to have max size in bytes instead of just size in items in the queue. And we can even do some, if let's say it's necessary for us to not drop any requests on the floor, we can even do stuff like save the request to disk when the queue gets full. We can do anything that our business, to cater to our business needs. So to create our memory-friendly queue, we write this module that will implement jobs queue behavior. And we have to implement this, all of these methods. We can, of course, steal most of them from the queue that comes with the jobs framework. And this is how we set it up. Now, this time, we didn't actually have this module parameter before, because it's by default was using the jobs queue the default queue, but now we are actually going to use our own queue instead. So now we have max size in bytes, and now we're going to have, so when we use our memory-friendly queue. Next thing would be really nice if our queue was reacting to the memory situation in our system. So for that, we can write a free RAM sampler, and let's say we want our queue to change the size as the memory situation changes in our system. So we're going to write our own sampler called free RAM sampler. We can use OS-mon memsub process to feed the memory information. And this is how we do it. Again, we implement job sampler behavior, and now we're gonna take a look at how to implement the sample method. We're gonna get the information from memsub get system memory data and feed it into this structure. That's what it returns. We only care about free memory. And this, by the way, is Erlang pattern matching. We do it with Erlang pattern matching. So now the question is actually how do we adjust max queue size on the fly? And this is how we can do it. We call jobs modify queue, and we'll modify our memory-friendly queue to have a different max size than we had in our configuration, if you remember. So now max size is going to be something different. We can change it on the fly based on the results we get from our free RAM sampler. But how do we actually do it on the fly using the jobs framework? So the answer to that is a little less straightforward than before. There isn't really a very straightforward way to do it. So we can either ask Ulf to add this functionality to the jobs framework, and I actually should have asked him a long time ago, but I didn't follow through since my last presentation. And so it's still not there, but maybe we'll ask him after this presentation. And the other thing we can do is we can actually expand the jobs framework by and help the Erlang community grow and add this functionality, consider adding this functionality ourselves. Ulf wouldn't mind. He's very busy with developing other projects. And if you don't want to do any of the above two things, we can just use the existing backdoor in the jobs framework. It can be done today. So this is how we do it. In our own process, we can subscribe to the job sampler. So we can use the job sampler framework in a variety of very flexible ways. So this is what we do, just call job sampler subscribe. And now our process will be getting this sampler feedback in its mailbox. And now that we get the feedback, so we know what the sampler framework is giving us, we can simply adjust the memory-friendly queue size on the fly. Hope that makes sense so far. So to kind of go over what I talked in my presentation, I would like to go through this very simple short quiz and some true or false questions. So spawning processes in Erlang is very cheap. Spawn all you want. Is it true or false?
First statement is true, the second statement is dangerous.
It can be very cheap unless you trigger a bunch of copying between processes. Like your arguments get copied, so if you spawn stuff to large objects in your arguments, they can be expensively copied.
The actual Erlang process is pretty cheap. If you're talking about some more complicated situation, like when you actually have a process that, what is it copying?
arg. So you start link a process, give it some args. So generally you don't give it any args. The process just starts up.
Yeah, and actually that's kind of going to come in the next question. Yes, you can if you need to spawn processes like I was doing it with the requests, so the request, they're sort of independent processes that I was talking about, right? So you need a process, you can spawn processes you can spawn a separate process for every request that comes, let's say, to your server. That's you don't know how many, you can have thousands of them coming in, and you just spawn a new process, and that's perfectly okay. But they are independent processes, you're not copying any information between them. Because web requests are independent, they're completely independent in nature, and you can just dedicate a specific process to your request. It's actually try doing that in Java. That's crazy. You're not going to have a thread per request. It's just not going to work. But this thread and process in the Erlang process are not the same thing. So it's true, at least in my that's the way in the situation that I was going through. So now the question is, you don't have to worry about what kind of work these processes are doing. Erlang VM will just make sure everything automatically works. So you don't really have to, you don't really need to, so you spawn these processes and you don't really have to worry about what they're doing. Is that true or false? Barbie?
Is it allowed to say it depends?
Yeah, sure. You can always do things and not worry about what's going to happen later. So as far as I'm concerned, it's false. We really need to, as you spawn, like we did with the CPUs, as you spawn thousands of processes, which is perfectly fine. You have to understand, are these processes going to take up all my resources? What are they going to actually do? And as far as spawning processes is one thing, consuming resources is a completely different problem. You actually have to understand what are those processes doing and what resources they're consuming and whether you're going to have any resources reasonably allocated. So next question is, load regulation is a pretty trivial problem. You should just consider writing your own library and not depend on some other people's bugs.
True if Wolf is in the room, I guess.
Pardon me?
True if Wolf is in the room, I guess.
And it's false if he's not?
Well, yeah.
Actually, well, considering this in the context of this presentation, it's false. But if you have a lot of time on your hands, you want to write your own library, then it's true. But no, but the load regulation is not trivial. It's basically, at first we were thinking, oh, just limit the number of requests to a certain number. That's very trivial. That actually could be done. But as you go on, you realize, oh, wait a second, we need this and we need that. You might actually discover a lot of other problems as you go on, and then you will be regretting that decision. Because if all you want to do is write a framework, that's one thing. But if you really need to solve a business problem and you have deadlines, you might not want to be spending your time reinventing the wheel. And well, the last question is, write your CPU-intensive computations in C and let Erlang manage concurrent execution. Is that true or false?
That's true.
Anybody disagreeing? Anybody wants to write computationally intensive, CPU-intensive computations in Erlang? No? All right. All right, that's the quiz is over. Everybody got an A, regardless of the answers. So time for questions.
So you have limiting, and then you have queue size limiting. What does jobs do when it can't service a request? So you've gone past both of those limits. Yeah.
So basically, it depends on what your business situation is. So if your requests are not important, like for advertisers, Yeah, just drop them on the floor, right? But if you're some kind of financial institutions and the requests are important, you still don't want to flood your server, right? You want to control the pace. So you can write your own queue that will do something. You will not dump the requests on the floor, drop the requests on the floor, but you're not going to be overflowing your RAM either. So you can just, like, I actually had I don't know if that's the best thing to do, but you can write those requests to disks or to disk or do something else, like maybe send them to another server. I don't know, something. You can, with your own queue implementation, you could do anything. Because it's fully pluggable. That's the great thing about jobs, that it's very pluggable. You don't have to do any of the, you don't have to use the existing behavior.
So is the existing behavior is drop it on the floor?
Yeah.
Okay.
It's just basically won't allow overflow, it won't allow overload in your server, and that's what it's doing. But if you're concerned with requests not being served or completely lost, you should implement your own queue.
Okay. Thank you.
Is it reasonable to dynamically create thousands of queues at runtime, or is jobs more about you sort of predefined a few queues that you don't need before the app starts?
I don't think you can create queues. The whole point is you probably won't need to create so many queues. Just I can't think of a business case where you would be creating queues on the fly. Okay, no, it's interesting. It cannot do it. A queue has to exist, and you register it during.
In which case, can we use the sampling stuff separately from the queue?
Pardon me?
Can I use the sampling counter set actually have the queue?
I'm not sure if I get the question. How?
I do have a use case where I want tens of thousands of queues.
You need thousands of queues, tens of thousands of queues.
But if I can't do it with the job straight up, I take the bits of it and build something myself.
But you need different types of queues.
No, they're all the same type, but they're going for different processes.
Oh, different queues.
So I've got a bunch of HTTP endpoints.
Okay.
These are all live Erlang processes, and I want to rate limit each of those.
But they're going to be at the same kind of queue, right?
No,
Is it?
one queue each.
I'm just so with the queues, with the jobs, you set a type of a queue.
Yeah, I'm going to need 10,000 queues.
No, jobs is not. Jobs is not. That's not what jobs is. Yeah, that's not what jobs is for. It's more for regulating your server than, creating.
I can see places where I need to use this standard job framework for other bits of logic, but this I have a particular use case.
Actually, it's a very interesting question. It's quite possible that the jobs queue could be expanded to do something like that. It would be a nice thing to explore.
You mentioned that you are using excellent tools to do some conversion like slots, right? You are calling them from Erlang, right?
We call them from. We were calling them from Erlang, yes.
So my question is, if the slots process for whatever reason becomes unresponsive,
Okay.
how do you know it's unresponsive or just running?
Actually, I think that if I run a process that just became unresponsive, it's going to just get killed by the supervisor, by the Erlang supervisor. I can have the process just get. If my Erlang process is running for too long, Erlang processes are always you always set it. They're not always supervised by default, but if you're following the standards of if you're following proper standards, you'll have your processes in your server supervised. So if your process is running for too long, you can just be killed by a supervisor. No, we didn't use NIFs or port drivers. We actually just call the external program, the external. Yeah, we used CMD. But to your question is that the process that just runs for too long can be simply killed by the supervisor.
It's hard to distinguish between a responsive process and something we have or something which is just running and taking time. That's why.
Yeah, the beauty of Erlang is that it doesn't matter what you called from your process. It can be just killed. And you cannot do this in any other, you cannot do it in other, like if you can do it in Erlang VM, you cannot do it in JVM, for instance. You can't kill a process that's actually doing something. And that somehow doesn't register to many people. They don't understand, like a lot of Java developers don't understand that they cannot kill a Java process that's busy, that's busy doing something. You just can't kill it. You can in Erlang.
Does jobs have the current framework implementation, the ability to manage dependencies? So for example, if I have 4 jobs, A, B, C, and D, and I want jobs A and B to execute, but D to execute after A and B has completed, can I actually set up a dependency chain within the jobs so I can handle the whole batch and know that when I get the result, they've executed parallel, but within some kind of dependency order?
So the question is whether we can have prioritize the items in the queue. Yes, you can by writing your own queue implementation. That's jobs doesn't have that out of the box, but you'll have to write your own queue implementation, and your requests will have like a priority on them, and you basically will order them by priority or something like that. But yeah, that you'll have to write your own plugin for that. Yeah, we looked at others, and we decided to use jobs. Jobs is actually more, it has more functionality in it, though we ended up using only the counter-based and rate-based regulation, and it just works. You can solve a lot of problems with just that, but if things get more complicated, the thing is that it's nice to have a framework that's pluggable, that's extensible, because very quickly your situation might get much more complicated than you realized. It happens all the time. So we ended up being okay with just those 2 regulations, but very often you realize, oh gosh, I need this and that. And if the framework is flexible and pluggable, you can always add to it. You can write your own code and plug it into existing pieces. So that kind of gives you a warm, fuzzy feeling that, okay, if I need more, I can always put it in without completely changing everything I did before, if that makes. Any more questions?